Hi everyone, Gio and Soren here with a little update on the development of Heli.os. We're finally finished writing funding applications for now, and it's not as fun as directly working on the game, but we really want to make this opportunity count and we're trying to find the fun in writing as well. And we were really deep in the process these last weeks, so sorry for missing a few uploads. Hopefully it should be better now.
A fun task we worked on this week are prizes for the component Diagnostic Tool competition. We are spoiling a bit here, so feel free to skip to the next timestamp if you're one of the winners. With that out of the way, what we decided to do is to ship physical versions of the components in the game to all of the winners. Whenever you want to bring in something from a video game into the real world, you realize all the discrepancies where things don't really make sense physically. In video games, there's nothing really preventing you from having elements that are just magically floating there. But if you give that to a 3D printer, it becomes very confused when it realizes there's such a thing as gravity. First thing we had to do was make sure that there weren't any of these errors in the component that we wanted to print. So after a bit of cleaning up in Blender, that part was fixed. Next step was to figure out how to make everything fit together. And here we gave ourselves a bit of freedom in order to experiment, to improve our skills for new rounds of merge. We decided to give ourselves a challenge and make so that everything could be assembled without the use of adhesive. This is done by having all the parts click together, which I think should be very satisfying when everything is properly measured out. There are two types of joints we use so far. There's a classic snap fit joint that you might recognize from your backpack or similar items. Then there's a more spicy one called an annular snap fit joint, which works the same way, but it's just rotated around itself so it becomes round. The cool thing about 3D printed items is that experimentation is pretty easy and forgiving. So we've already tested a few attempts that didn't quite work out as expected, but it makes it super easy to fix. Oh, and we'll of course also be shipping the sockets too, and ensuring that everything snaps together nicely with magnets embedded in the 3D print. We already know there are some as far as Russia, so figuring out shipping now is probably going to come in handy in the future if we ever make another batch of merge.
Early in the process of building our studio, we've talked with industry veterans to better understand tricky processes and key aspects to focus on when developing Heli.os. One of these veterans, who ended up joining us as an advisor, is Soren Lundgaard, CEO and co-founder of Ghost Ship Games, creators of Deep Rock Galactic. During a conversation with him, he expressed how important it is for the character control of a game to feel responsive and to meet expectations, especially in a third-person game, such as Heli.os. We fully agree with his take, and that's the reason why we decided to focus on development of a great character controller from the early stages. We've talked about our controller in our first devlog, and we kept working on it since then. For starters, the dash bug that was showcased in the video is gone, and the dash now fully supports slopes and obstacles. We've also researched how the games that inspire us design their player controllers, and tried similar approaches. For example, we've done a lot of camera work inspired by games like Returnal and Dead Space, making sure that looking around and aiming feels smooth and intuitive. We've also included a lot of quality of life improvements, such as sliding off corners, pulling the camera closer when the view is occluded, and more. In short, we have developed many features and know what to do next to improve it even more. There is still a lot to do, and we know even more adjustments and fine tweaks will arise as we keep developing, but we are going to soon start testing it internally. Overall, we're very proud of what we got so far and can't wait to know what people think when they get their hands on it.
Hey everyone! This week we played around with motion capture, and here's how that went. This week we also started testing out a mocap system called Rococo, which we are lucky enough to borrow from a friend. Once you have it set up, it's really cool to see your motions on screen as a digital double. And there are some very obvious pros of recording mocap animations instead of painstakingly animating everything by hand. But wow, setting it up for us was a huge pain. For some reason the suit refused to connect, even after I brought my router from home, until suddenly it just randomly worked. These tasks where you have to press buttons in a magical order until it suddenly works are quite demoralizing to work on. And just to spice it up for ourselves, we decided to throw in a few extra steps for the future. But first, let's tell you some about the downsides that we are trying to fight. First, mocap is typically really expensive if you want a studio. It's cheaper with Rococo, but still costs a lot. Also, motion capture data is typically pretty messy and needs to be cleaned up. From my experience, Rococo's data is pretty good, still not perfect. And motion capture is also not a magic bullet. It feels like acting inside a fixed suit. The motions are just a little different from yours, and you really have to sell it. So if you want a cool backflip in your game, you probably still have to do traditional animation. The final issue is that the mocap data is not clean like animations done by hand. There are not any keyframes and everything is just recorded all the time. So we thought of a workflow that can hopefully make these paints a bit less severe, and a really big one is to make it possible to tweak these animations by hand in case our acting skills aren't sufficient. So the goal is a workflow something like this. First, you create your character in Blender, which is our 3D modeling program. Secondly, we rig it in a way that is supported by Rococo Studio, where we record the mocap. Then, I found around 20 steps inside Cascadeur, that is required in order to unbake the motion capture, turn it into keyframe, and finally allow you to work with the data. We hope that when this workflow is matured, we'll be able to create lots of cool animations with personality and within a short time frame. We can't wait to have the animations ready and hook them up to our character controller.
Join our Discord server at ourdiscordserver.com to stay in the loop for more updates. And thanks for sticking through and watching this video. Bye. That was cool.